out there in YouTube land? How you doing today? What's that? You're not doing too good. Why? Too early in the morning for you? Or you didn't have your coffee yet? Well, go grab a cup of coffee and come back to this video here and I'll explain some things to you. This is dedicated to the people out there that want to work on antique radios and so on, even televisions. As I had mentioned in previous videos, never take and plug an old radio in when you first get it, because the electrolytics and so forth could be shorted. There could be a short somewhere in the radio, and you could do more damage to the radio than you'd care to know, especially the power transformer. They're almost impossible to replace, or very difficult to replace, to get a replacement for some of these power transformers in some of these antique radios. Now I'm talking about radios that go back to the 30s and the 40s. I'm not talking about transistor radios or stuff like that. I don't get into that, although I have serviced them in the past, but with my eyesight and so forth, I don't do that anymore, and of course I don't have a shop anyhow. But being that I don't have a shop, I'm out here in my shed, as you can plainly see by the familiar surroundings that you have seen in other videos. And I don't have anything here in the shop that's anything to do with electronics whatsoever. All my stuff is tools and stuff. I have electrical tools and things to do electrical work with, but I don't have anything in electronics. I have a small digital multimeter for stuff around the house here and so on, but I don't have any of the test equipment. All that shop stuff, what I did save, is in storage now. So what I'm going to try to do is explain what gray matter I got up here, what I can remember, what I got left up here in the way of gray matter, to be able to transfer some of that gray matter information out to you. The thing you have to watch with an antique radio or a television is the electrolytics, which are the main filter capacitors after the transformer and through the rectifier, are the main reasons why you do not plug an antique radio or television into an outlet before first running it into a dim bulb tester, which I have explained on another video, of an earlier video that I have here on YouTube, when I did have my shop. So what you're going to do is to replace the electrolytics. I don't care if you don't have a hum. You get a radio and hey, it has a hum in it. Well, first of all, you shouldn't have plugged that thing in the first place, because you're lucky that it only has a hum and it didn't cook the transformer. So do not plug an antique radio in, especially something that's 30, 40, 50, or 60 years old, without first running it through a dim bulb tester. It shows up that it works okay through that. You're still going to replace the electrolytics. Bottom line is, you do not leave any electrolytics in. And I have seen in my years of working on these things, as a hobby of course, never in a business, is the fact that the electrolytics I have seen cases where some technician, so-called technician, has bridged over an electrolytic right over the top of the defective one without cutting the old one out of the circuit. You don't do that. But what you do is, the electrolytic, for cosmetic reasons, you leave the old can sitting on the top of the chassis. Underneath, nobody's looking underneath. It's not going to the Smithsonian Institute. So don't worry about the underneath, unless you've got an antique radio, real old in the 20s, where yes, everything's out and you want everything perfect, like an Atwater Kent. Well, that's another issue altogether. Then you want to have everything original. But I'm talking about a radio like my Crosley Model 158, for instance. Your electrolytics cans would be on the top of the chassis, but electrically disconnected underneath, and then new electrolytics are added on terminal strips, so that essentially when you open up, look at the back of the radio, everything looks original. Underneath the chassis is where all your modifications are taking place. Well, it's very difficult without test equipment, a bench, and so forth, to actually show you what I'm trying to explain here. I can't even sit and draw a diagram. I tried doing that, and I'm such a horrible artist in drawing things that I can't even make the diagram out myself of what I'm drawing here. So I'm at a big disadvantage, and this is why I have been kind of like putting off doing these how-to videos pertaining to the antique radios and so forth. Because without a shop and without pulling out a schematic, like I say, I have nothing here in the way of radio schematics books or anything. So I can't pull out a schematic and start showing you, you know, this and that as to what to look for, because I just don't have those things here. And everything is out of the shop as far as that stuff is concerned. I'd like to touch on one other thing, though, that questions have come up to me about replacing electrolytics and the values and so forth. On your real old radios in the 30s, a lot of the electrolytics weren't any more than 8 microfarads at 450, 475 volts, depending. They used a relatively high voltage, but the capacity was low because they did not have any electrolytics. What they had back then, and some of your real old ones, was just basically capacitors. They weren't even electrolytics on the real old sets. The sets in the 30s, later 30s, had electrolytics, and they were the wet type. Those dry out and have to be replaced, but you leave the can on top of the chassis for cosmetic reasons, and make the radio as original as possible and do all your work underneath. On those wet electrolytics, they're mounted usually on an insulated wafer, and they have a big nut on the bottom of them, the thread and the nut that holds them onto the chassis. They're not a twist lock electrolytic like on my dad's old 87K RCA radio. That was a late 30s model, and that's what that used. It also used 16-volt bias for the output tubes, and so therefore those electrolytics, they were not grounded to the chassis, they were on an insulated washer. If you make the mistake and replace your electrolytics and ground the negatives to the chassis, you're going to lose your bias on your audio output tubes, and then you're going to have some problems. So that has to be replaced electrically exactly like it was originally. So what I usually do is I take off the center post of those wet electrolytics, disconnect it, so just leave it hanging. I take a terminal strip, the little grounded lug on the terminal strip, I'll solder that right to that little nipple hanging down where the hot terminal is on the old electrolytic, the old wet electrolytics I'm talking about. That's my tie point. And then bring in my negative and positive of the new electrolytics onto that terminal strip, because usually you'll have 2 or 3. You should get a terminal strip with like maybe 4, not counting that center lug, because you're not using that. That's just going to be holding it there and soldered into place. That way you don't have to drill another hole in the chassis and mount the terminal strip. That's the way I've done it with that radio and a lot of others that use those type electrolytics. So again, make very sure that you electrically keep the set just like it was originally. I think that's about all I can discuss now in this short 10-minute of a video that YouTube will limit me to. So I wanted to let everyone know out there that the ones that are into antique radios and televisions, my YouTube fans, that I did not abandon you. I'm in a precarious situation here where I'm not able to do what I'd like to do and discuss these things with you. So if you bear with me on this, once in a while I'll come out with a video, and when and if I ever get a shop set up, we'll be glad to do those at that time and do a lot more of them. Until then, thank you all for watching. You have yourself a good day, and don't drink too much coffee. Good day.